Okay, so let's just try and do a little bit of consolidation now for variation of parameters. Okay, it's kind of the general method of solving any order differential equation. Okay, so it's really important. So we basically have, let's just consider a second order differential equation like this. Okay, where a and b are just sensible functions. And basically, first things first, step one is solve the homogeneous equation. Okay, solve the homogeneous equation. Okay, so therefore you'll get two solutions in this case, y1 and y2 out. Okay, and you say that the general solution is going to be the complementary solution, so yc. Okay, general solution for the homogeneous case is going to be c1y1 plus c2y2. Okay, and then from this, so the second step, I suppose, is from this we can build our non-homogeneous solution. So we build the non-homogeneous equation. So if yc is equal to some constant times y1 plus another constant times y2, then the non-homogeneous is a little bit more grown up. So therefore, instead of just values, we basically use functions. So therefore, it's going to be y is going to be some function u1 times our first solution plus some function u2 times our second solution. So that's basically the solution which we're looking for. Okay, then the third step is just simply to solve what u1 and u2 actually are. So actually solve what u1 and u2 actually are. Okay. Now, in order to do this, we basically end up with a differential equation. A simultaneous equation. And in order to do that, you have to. So the way which you do that is basically take that, okay, and sub it back into your differential equation. So you'd have to find the first derivative and second derivative, etc. Okay. But basically, you'll end up with something that's looking a little bit like this. So u1 dash times y1 dash. Plus u2 dash times y2 dash equals qt. Okay, so that's basically, you'll end up with something like that. But obviously that's not good enough just to solve what u1 and u2 are alone. So therefore you need to impose another condition. And the other condition is that u1 dash times y1 plus u2 dash times y2, that's got to be equal to 0. Okay, so that's the other condition. That's the kind of crucial condition that you also have to impose. It's kind of a little bit subtle. It's not obvious, but you have to also impose that condition. And again, we talked about that. It's basically, you can't solve that alone. You need another equation, and you can see that by the Lagrange equation that must be true, but we don't go into that at all. Okay, and then basically, so basically from this, go away. Then basically from this, you can find what u1 dash is equal to. So u1 dash is equal to that. u2 dash is equal to that. So I suppose step four is to solve u1 and u2. So you've found u1 dash and u2 dash from this, perhaps. So in step 4, I suppose I kind of hid it in there, but u2 dash is, so step 4 is to find what u1 and u2 dash actually are. Okay, and in actual fact, they will follow very much the same kind of form. So providing that y1 and y2, remember y1 and y2, where are we? Y1 and y2 is what you built your non-homogeneous solution from. Okay, so basically, if y1 and y2 are fundamental, that is that one can't be written as a multiple of the other. Okay, we've talked about that in kind of a few previous videos. So one can't be written as a multiple of the other one. So therefore, we can basically say then that u1 dash will always follow the form of y2 times qt over the Vronskin, okay, because y1 and y2 are fundamental, so it'll be over the Vronskin, okay, and u2 dash will always follow the form y1 times the same thing, q2 over the Vronskin. So basically, if you can find the Vronskin, so, you don't have to go through all the different processes. This is if y1 and y2, by the way, are fundamental. If they're not fundamental, you have to go through the same way, so, the same solution we had before. But this is actually a really nice shortcut, so you don't have to go through all of the long method that we went through in the middle. It's not really that long, I suppose. It's just really kind of subbing back in, differentiating and subbing back in. But basically, you know that u1 dash and u2 dash are going to follow this form if y1 and y2 are fundamental. If they're fundamental, then you can just basically jump straight to this. So it's a shortcut. Now, shortcut doesn't necessarily mean that it's nicer, because it may not be nicer, but yeah, basically you'll end up with this, and so therefore you can say that u1 is just going to be the integral of this. So in other words, u1 is going to be the integral of this with respect to t. u1 is going to be the integral of this, and u2 is going to be the integral of this with respect to t. u2 is going to be the integral of this with respect to t. So yeah, basically, you can form this, and then it follows that the general solution will follow the form of, basically, when you get this out, you find what u1 and u2 is. So obviously it's going to be equal to this, so u1 times y1 plus u2 times y2, okay, and it will still follow the form. You'll see that it still follows the form of c1 y1 plus c2 y2, okay, plus some extra bit, and that basically follows the form of yc plus some kind of extra bit. Okay, so that's basically the general form. That's the general form.